This object is totally alone out there right now, moving so fast it will never see another star again. Not in 1,000 years, not in 1 billion, not ever. What could possibly get launched out of an entire galaxy? And what happens to something sentenced to drift through pure darkness for eternity? By the end of this video, you'll understand the most violent physics in the universe and why they created the loneliest object we've ever found. Let's get into it. So here's something most people don't realize. Our galaxy, the Milky Way, isn't just sitting there holding onto its 100 billion stars. It's losing them. For decades, scientists figured that maybe one star got kicked out of the galaxy every 100,000 years. That's basically nothing. One star, gone. And then silence for longer than human civilization has existed. But here's the thing. The European Space Agency's Gaia mission has been mapping the precise positions and velocities of over 1 billion stars in our galaxy. And it turns out these so-called hypervelocity stars are way more common than anyone predicted. A hypervelocity star is a star moving so fast that the entire gravitational pull of the Milky Way can't hold it. We're talking speeds north of 1 million miles per hour. For context, our sun cruises around the galaxy at roughly 450,000 miles per hour, which sounds fast until you meet one of these things doing triple that speed or more. The fastest one we've ever clocked? A star called S5HVS1, screaming through space at about 3.7 million miles per hour. That's fast enough to get from Earth to the Moon in about 6 minutes. If you drove from Los Angeles to New York, that's about 2,800 miles. S5HVS1 covers that distance in under 3 seconds, and it's never coming back. So how do you throw a star out of an entire galaxy? You need one of two things: a supermassive black hole, or an explosion so powerful it redefines the word violent. Let's start with the black hole method. Picture two stars orbiting each other, a binary system. Now imagine they wander too close to Sagittarius A star, the supermassive black hole at the center of our galaxy, which packs the mass of 4 million suns into a space smaller than Mercury's orbit. What happens next is brutal. The black hole's gravity rips the pair apart. It captures one star, dragging it into a tight orbit. But the other one, it gets launched outward like a rock from a slingshot. This is called the Hills mechanism, named after physicist Jack Hills, who predicted it back in 1988. It took until 2005 for astronomers to actually find the first one. But there's another way, and it might actually be more common. It's called a D6 supernova. That stands for dynamically driven double degenerate double detonation, which is a mouthful, but here's the simple version. Two dead stars, called white dwarfs, orbit each other. One steals material from the other until it hits a critical mass and detonates in a thermonuclear explosion. The companion that survives. It gets blasted away at over 2 million miles per hour. A 2023 study led by astrophysicist Kareem El-Badri at Harvard found 4 new hypervelocity stars created exactly this way. When they ran the numbers, they estimated the Milky Way may have already launched more than 10 million of these things into intergalactic space. 10 million stars, just from our galaxy. Drop a comment if that number shocked you, because it shocked the scientists too. Okay, so ejecting a star is dramatic enough. But what if I told you we've now confirmed that entire supermassive black holes can get kicked out of their galaxies? In 2023, astronomer Pieter van Dokkum at Yale was doing something routine. Cleaning up Hubble's Space Telescope data, removing streaks caused by cosmic rays hitting the detector. But one streak wouldn't go away. It showed up in every single image. And that's when things got interesting. We talked to Pieter about what happened next.
I had done the work of removing the cosmic rays, at least that's what I thought, the artifacts. And then there was one left. And I was like, that's not, why did that not work? And then we took spectroscopic observations with the Keck telescope. And that showed that, first of all, it was very far away. And so, halfway across the universe. And it had a spectrum that is extremely unusual, like it had very large amounts of ionized oxygen, which is something we had not expected to see. And after that, it became the classic Sherlock Holmes thing of trying to rule out the impossible. And then what we were left with was a runaway black hole at that point.
So what Peter's team had found was something no one had ever seen before. At the tip of a trail of bright blue stars stretching 200,000 light years across space, twice the diameter of our entire Milky Way, was a runaway supermassive black hole. And how big is 200,000 light years?
If you traveled from where we are in the Milky Way to the heart of the Milky Way, the center of the Milky Way, and you did that 10 times, then you've covered that distance.
10 trips from here to the center of the galaxy. That's the trail this thing left behind. And the way it created that trail is wild. The black hole, 10 million times the mass of our sun, is plowing through the thin gas between galaxies so fast that it creates a shockwave. That shockwave compresses gas, and that compressed gas collapses and forms new stars. As Peter put it, it's like a ship leaving a wake, except the wake is made of newborn stars, and the ship weighs 10 million suns. But back in 2023, this was still just a candidate. A really exciting candidate, but they needed proof. They needed to see this thing actually moving. And that's what the James Webb Space Telescope gave them. Webb is vastly more powerful than Hubble, and what it could do that Hubble couldn't was measure how the gas around the black hole was moving. The black hole pushes against gas in front of it, and that gas flows around it like water around a rock.
Until then, we're like, well, we see a streak, and we see some gas that's highly ionized. But now we see something moving. And so if you want to say that something ran away from a galaxy, what you want to see is you want to see it move.
Webb measured those motions, and from those motions, they confirmed the speed, roughly 1,000 kilometers per second. That's about 2.2 million miles per hour. So this thing is confirmed. RBH1, Runaway Black Hole 1, is real. But what could possibly kick something that massive out of an entire galaxy?
If another galaxy comes and that merges with this galaxy, so they collide and then turn into one new galaxy, the black holes of those two previous galaxies end up in the center of the newly formed galaxy. Just like the Milky Way and Andromeda, they will merge with each other in about 5 billion years or a little longer. And each galaxy has a massive black hole at its center. So when the Milky Way and Andromeda collide and then form a new galaxy ultimately, those two black holes, where do they end up? In the center of the new galaxy. And those two black holes, they will in-spiral towards each other and ultimately merge with each other. That moment of the merger can create a kick. It's predicted by general relativity that the merger itself, particularly if the black holes are spinning, can then send the black hole flying.
So now picture that. A black hole, millions of times the mass of our sun, born from the violent merger of two others, rocketing through the emptiness between galaxies at over 2 million miles an hour. No galaxy to call home, no stars to orbit it, just pure, uninterrupted void stretching in every direction for millions of light years. That is the most alone object in the known universe. Let's sit with this for a second. Intergalactic space is the emptiest environment that exists. We're talking about 1 atom per cubic meter on average. For comparison, the air you're breathing right now has about 25 billion molecules per cubic meter. Intergalactic space is, for all practical purposes, nothing. And this runaway black hole, or a hypervelocity star like S5-HVS1, is heading deeper into that nothingness with every passing second. No friction to slow it down, no gravity strong enough to pull it back. It's been sentenced to solitary confinement for the rest of time. But here's something Peter told us that we genuinely didn't expect.
I imagine that people think, is it coming towards us? Actually, it kind of is coming towards us. By the way, as it happens, it is coming towards us. It'll pass us. And actually, the universe will expand so much that the thing will never reach us. But yeah, it's not something to be worried about. It's something to marvel at.
Yeah, the runaway black hole is technically heading in our direction. But before you close this tab, here's the thing. The universe is expanding faster than this black hole can travel. It will never reach us. Not in 1 billion years. Not in 1 trillion. The space between us and this black hole is literally growing faster than it can cross. But the fact that it exists at all raises a much bigger question. If this happened once, How many times has it happened?
We see galaxies merging all the time with each other, and something has to happen to those black holes. What we didn't know was how to find them, because they're black. They do not emit any light by themselves. We have two telescopes, Euclid and Roman. One is already up in space, and the other will be launched next year, that will survey vast areas of the sky with almost the same resolution as the Hubble Space Telescope. And that should allow us to see more of these very thin streaks that first drew our attention to this object. So I expect actually that we'll see a lot more of these in the future.
So let's bring it back. We started by asking what the most alone object in the known universe is. And the answer is something almost too dramatic to be real. A supermassive black hole, confirmed by the James Webb Space Telescope, hurtling through intergalactic space at 2.2 million miles an hour, leaving a trail of newborn stars 200,000 light-years long, with no home to return to. It was predicted 50 years ago. It was spotted by accident, and it's technically headed our way, though the universe itself won't let it arrive. But it's not the only one. Every galaxy is quietly ejecting stars and black holes into the void, building an invisible population of cosmic drifters we're only beginning to detect. The universe is full of loners, and we just learned how to see them. Here's what I want to know from you, cosmonauts. What do you think is more unsettling? The idea that these objects are alone forever? Or the idea that the void between galaxies might be more crowded than we ever imagined? Drop your answer in the comments. And if you want to know what happens when galaxies collide and why the Milky Way's next collision might create even more of these cosmic exiles, watch this video next.